It is indeed, we are living in a world of patterns, including lines, shapes, or movements. Wherever we may go, it is inevitable for us to observe a variety of patterns in our surroundings, such as seeing the animal skins, which are also covered with patterns of spots,
like zebras and tigers. The movement of the sun, in which it rises from the east and sets in the west. The design of the waves on the sea. The undulating ripples of a desert dune. The circular movement of planets by following their orbits. The movement of whirlwind and whirlpool are also examples of things that have a pattern.
Such these things could not only be seen in our naked eyes, but even the way we live, there is also a pattern. One observable type of patterns in this lesson is Fibonacci sequence. The term Fibonacci was derived from the name of an Italian mathematician, Leonardo Pisano, also known as Fibonacci, which stands for Filius Bonacci, means son of Bonaccio. This Fibonacci tells that the simplest mathematical objects are numbers, and the simplest patterns of our nature are numerals. This type of pattern has the sequence of 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, and so on. This pattern is often associated with nature, such as flowers. In this collage, we can observe flowers that belong to this sequence, like having 2, 3, 5, 8 petals.
A tessellation is about the patterns in a covered surface with no overlaps or gaps. A tessellation is created when a shape is repeated over and over again. There are different types of tessellations: the regular tessellations of triangles, square, and hexagons, a semi-regular tessellations with triangle, triangle, square in cyclic order at each vertex, a shorthand notation Shuffle symbol with 3, 3, 4, 3, 4, and we have the irregular types too. Tessellations are the most common thing that we can witness even at the comforts of our own home. From the concrete wall, a weaving basket, a rug, banig, crocheted blanket, crocheted top, sawali, and even the brick floor or tile floor can exhibit a pattern of tessellation. It's so easy to find tessellation pattern to an existing object. However, we usually witness a tessellation pattern all put together, already to its final form. But the tessellation wants us to learn is that even to the smallest part of a piece brings the whole piece together. When the smallest piece went missing, the whole pattern will not be completed.
A fractal is a distinctive pattern observed in nature that was first termed by Benoit Mandelbrot in 1975. A fractal is a true and stunning blessing of extravagance and structure from the God of all. When you see a set of patterns repeating over and over again at many various scales and where any small component mirrors the total. The tree, for example, has a branch from the trunk to the tip that is a carbon copy of the tree itself. Its shape is similar to that of a tree. A river, on the other hand, is an example of a fractal. Each stream resembles the main river, with minor streams resembling the larger streams or even the river itself. The same may be said about the three plants depicted here.
As we took pictures, a trip to nature from our respective home and community, we have captured pictures and then grouped it according to its nature pattern. As we go along to this activity, we realize that finding and understanding patterns give us a great power. With patterns, we can learn to predict the future, discover new things, and better understand the world around us. Thus, Through observation of natural patterns, we can see changes in the environment, and utilizing these observations, we can give some predictions to natural phenomena. It is said that patterns are clues to solve the mysteries of nature. Again, there are three types of patterns in nature: the Fibonacci sequence, tessellation, and fractals. The Fibonacci sequence is a famous group of numbers beginning with 0 and 1, in which each number is the sum of 2 before it. On the other hand, a tessellation or tiling is the conveying of a surface, often a plane using one or more geometric shapes called tiles, with no overlaps and no gaps. In mathematics, tessellation can be generalized to higher dimensions and the variety of geometries, while fractile is a kind of pattern that we observe often in nature and in arts. As Ben Weiss explains, whenever you observe a series of patterns repeating over and over again at many different scales and where any small part resembles the whole, that's fractile. So generally, pattern is fundamental for our understanding of the world. It is important element in every mathematics curriculum. We believe that nothing in nature happens without reason. All of these patterns have an important reason to exist, and they are also happen to be beautiful to watch.